Have you ever opened a soda, heard the psh sound, and noticed it slowly goes flat? Today, I'm going to show you how thermodynamics' two concepts, fugacity and phase equilibrium, explain exactly why soda loses its fizz. Inside this sealed bottle, carbon dioxide is in equilibrium with the gas in the headspace and the dissolved CO2 in the liquid.
So at equilibrium, the dissolved CO2 in the liquid is equal to the CO2 in the gas phase over here in the headspace, which means that the fugacity in the liquid is equal to the fugacity in the gas. So in Thermo 2, fugacity in the gas is equal to phi, or the fugacity coefficient times y, the mole fraction, and times p pressure. And then in the liquid phase, it's the x times h. X is the mole fraction, and h is Henry's law constant.
When the bottle is sealed, the pressure in the headspace is high, several atmospheres of CO2, so the gas phase fugacity is large. To satisfy equilibrium, the liquid phase fugacity must match that, so the mole fraction of CO2 is equal to the fugacity divided by the Henry's constant. When I open the bottle, the gas space suddenly drops to about 1 atmosphere, exposed to air. The gas phase fugacity of CO2 drops dramatically because P and Y CO2 drop, so the fugacity in the gas phase becomes much smaller. But the liquid is still loaded with CO2 that was in equilibrium with the high original fugacity. Now the liquid has a higher fugacity than the gas, so CO2 starts to escape. Bubbles form, CO2 leaves the liquid, the soda slowly approaches a new equilibrium with a much lower dissolved CO2 mole fraction. That's the thermo definition of going flat.
And then here is a simple sample problem for this particular scenario. So we assume that temperature is constant, the fugacity coefficient is about 1, and we know that the fugacity in the vapor phase is equal to the fugacity in the liquid phase. So here, we follow our math. In a sealed bottle, the CO2 concentration is about 0.17, and then in an open bottle with a lower pressure, you can see that the CO2 concentration is about 0.017, and that's a 10 times decrease in why soda goes flat.
So next time someone opens a soda and complains it went flat, you can say, actually, that's just the fugacity of CO2 dropping and the system shifting to a new phase equilibrium. Thermodynamics 2 isn't just equations on paper. It literally explains everyday things like soda fizz. That's how cool Thermo is.